In this demonstration, we are going to show a more realistic deployment of API Connect. This API Connect deployment is going to be a multi-cluster deployment. We need to realize that clients these days have a multi-cloud hybrid landscape. By that, I mean that clients will have applications not only on premises, but also on the cloud, and not only in one cloud, but also in multiple clouds. So in this demonstration, we are going to see how API Connect can be deployed so that it accomplishes the requirements for these multi-cloud hybrid deployments. We are going to have the control plane components of API Connect, which are the management component and the developer portal component, running on one cluster, whereas then we are going to have the gateway and analytics components of API Connect running on those clusters where the client is hosting and running the different applications, and the client wants to expose the APIs of those applications through the gateway component of API Connect, so that that API is exposed on a secure manner, as well as it is published and socialized on the developer portal of API Connect. As you can see in the picture, these clusters can be on IBM Cloud or on Amazon, or really on any other cloud provider or on-premise data centers where Openshift is able to run. So Openshift is that platform that will standardize on top of the hardware and that will allow IBM software and IBM capabilities to run on top, regardless of, as I said, whatever is behind or sitting behind Openshift. Now, we want to do these deployments using GitOps. That means that the definition of what we want to have in our clusters, as far as API Connect or any other IBM software is concerned, will be defined as code in GitHub repositories. So similar to what we've seen in the recent years of defining your infrastructure as code, and defining the installation, configuration, and look of your Openshift clusters, we are trying to do the same with any IBM software or capability. We're going to be using the Openshift GitOps Operator, which is a native tool that comes with Openshift to take care of making sure that the configuration and components that we have defined in this GitOps repository in GitHub is what we actually have running on our clusters. Now, Openshift GitOps, as we will see in a minute, relies on Argo CD as the tool that will make that watching over what's on the GitOps repo and any changes on that repo and what's in the clusters. And if there is any drift in configuration, it will apply whatever action it needs, so that what we have running and how it looks on our clusters is what we actually have defined in our GitOps repo. Now, apart from being able to install and deploy API Connect and its different components in the different clusters to suit our needs and our scenario, we want to then configure API Connect on the more automated fashion possible. For that, we want to have the configuration of our API Connect, in this case multi-cluster scenario, as code stored in GitHub, and then use the Openshift pipelines to apply that configuration. Now, what that allows us is to have that configuration in code so that it's auditable and it can be applied to any other cluster. So in the case of a disaster situation, then we should be able to apply this very same configuration to a different cluster and have the exact same scenario as we used to have. So we are trying to minimize the manual interaction with not only the infrastructure and the clusters, but also to the IBM software running on those clusters and the configuration that we apply to those components or IBM software. Now, the last step, once again, is to be able to treat IBM API Connect citizens in the same way that we treat the components, the configuration, and anything that goes on these clusters, which is through code that is stored in GitHub. So in this case, we are looking at the product and API definitions that I publish on my API Connect instance, but doing it through automation from the definition of these that is stored in GitHub. And once again, we're using the Openshift pipelines to do that. So we can see that we will have our products and APIs defined in GitHub, and then have the Openshift pipelines being the one that will make sure that those definitions result on those APIs and products being created in API Connect. That will allow us to deploy and publish those APIs to the different gateways on those clusters where our applications are running, and be able to access those applications on a secure manner through those gateways. So we have 3 Openshift clusters already deployed, as you can see in the picture. One is deployed in IBM Cloud and will host the management and portal components of API Connect. Okay, the second one, as it was depicted in the diagram, will also be hosted in IBM Cloud and will contain the gateway and analytics components of API Connect. The last one is hosted in AWS and once again will contain the gateway and analytics clusters. Now, as I said, each of these clusters will have the Red Hat Openshift GitOps operator, and as I said, this GitOps operator relies on Argo CD available so that we deploy everything that we want through these GitOps processes. So you can see for each of these clusters, we have the Openshift GitOps operator and then Argo CD running on them, and you can see in Argo CD that there's nothing deployed on those clusters at the moment. The next piece is actually this GitHub organization where we have those GitOps repos that will contain the definition of the components, configuration, etc. that we want to apply to our clusters in the case of Openshift and to our instances in the case of IBM API Connect. Now, the one that will drive the entire process is called multi-tenancy GitOps, and this is the one that we are going to have a closer look at. So we switch to the appropriate branch for this demonstration, and then we're going to have a look at the structure of this project. So if we open up the folder 0-bootstrap, then we will see 2 profiles. So we will have a profile if we are managing the installation of components on a single clusters, but we also have the others folder that contain other profiles, and this folder will contain the multi-cluster profiles. So in this case, we see that we have a folder or a profile for our API Connect multi-cluster use case, and if we expand that folder, that profile, we will see that we have 3 other folders that correspond to each of the clusters that we've seen previously. So we will have one folder for the management and portal cluster, then we will have another folder for the cluster that is in IBM Cloud that will run the gateway and analytics components of API Connect, and likewise we will have that folder for the cluster that is running on Amazon that is hosting and running the gateway analytics components of API Connect. Now, if you look at those 3 folders that correspond to each of the clusters, you can see that the structure is the same for all of those, right? And that structure is divided into 3 layers. So we will have one infrastructure for driving and managing anything that has to do with infrastructure, such as namespaces, machine configs, or machine sets, storage, and so on. Then another layer that is services that will have to do with the software that will get installed and managed on our cluster. So things like, in this case, IBM API Connect. And then a third layer which will define the applications and all the things that will run on top of those services that we have deployed. But the thing here, the main important thing is that everything from one cluster to another is consistent. Now, within this GitOps framework, we're not only using Argo CD, but we are also using Customize, right? And what Customize allow us to do is to have this kind of like indexed files where we have a list of the different capabilities that the GitOps framework is able to install. So in this case, for instance, if we are looking at the management and portal cluster, we can see the different things that we want to install. So the first thing that we want to install is the IBM catalog so that we have access to the different IBM operators to install those IBM capabilities that we need to work with. The second thing is the IBM Foundations operator, okay, and the Data Power operator, which are dependencies of the API Connect operator. The last thing that we want to install is in fact an instance of the management and portal components of API Connect. So if we compare this index list with the index list of a gateway plus analytics cluster, then we will see that everything is exactly the same, but in this case we are deploying a gateway plus analytics instance as opposed to a management and portal instance. So the third cluster, once again, we are deploying the gateway and analytics instance. Now, on the application side, on the management and portal cluster, we are also deploying a couple of Openshift pipelines that will do what we described earlier in the diagram of, making sure that the configuration stored in GitHub is applied to our API Connect instance, and the other pipeline will make sure that the definition of the products and APIs that we have in GitHub get realized as products and APIs within API Connect. So we'll publish those definitions to API Connect. Now, if we look at the application layer for the clusters that are running the gateway and analytics component, we will see that here what we are deploying is that dummy application that you saw on the diagram, which will just give us back what cluster this application is running on. So the aim or goal of this application is that depending on what gateway we poke the API on, then it will give us back that the application is running on Amazon or in IBM Cloud. Once again, in this cluster, we see that we are deploying the application. Now, the last thing that I want to show is these bootstrap files. And if we open one app, we will see that it's nothing but just an Argo application. And this bootstrap application has the goal of bootstrapping your cluster. What that means by bootstrapping? Well, it's an Argo application that you can see is being passed what's the repo URL, the path within that repo URL, and the branch on that GitHub repo where we have stored the configuration and things that we want to get installed on our cluster. And this just points to the folders for each of the clusters that we just see. So all I need to do really to get the GitOps process started for each of the clusters we've seen here is create this Argo CD application. As soon as I create that Argo CD application, we see how Argo CD now, based on those parameters of the GitHub repo, etc., goes out to that GitHub repo and that path and within that branch and start looking at what needs to get deployed, what's being specified and configured to be running and deployed on this cluster. So here we are doing the exact same thing, but for the other two clusters. So we created this bootstrap Argo CD application that will in turn quickly go and look at that GitHub repo and see what's defined in there and what needs to be deployed on the cluster. So we do the same for the last cluster. And at this point, we should have the three clusters getting deployed and installed everything that we said on our on our GitHub repos. So we see how the different operators that, remember, I went through on that index file, that customization.yaml file that serves as an index of what we want to get installed. We can see how these are being installed at the moment, and we can see that for each of the clusters. Now, after some time, we can see that all that we have specified on that index list is being installed. So we see all of the operators that we said we wanted to get installed in each of the clusters. But not only that if we go to the Argo CD web console, we can see all of those Argo applications that are just pointers to where in my GitHub repo is code and definitions and all of that are green. So everything looks fine in our clusters. Now, if we close that, we can go and check the operators that are within the tools namespace, because here is where we are installing the components or different components of API Connect depending on the cluster that we are on. So looking at the management and portal cluster, we can see within that API Connect operator on that tools namespace that the instances, the components of API Connect that we have deployed is the management and portal. Now if we go to the gateway and analytics cluster and we do the same check, then we should see that what we have deployed here is the analytics and gateway components. And likewise, we should see the same in the Amazon cluster. The last thing that we are going to do related to the installation is to open the API Connect Cloud Manager and logging into that Cloud Manager and realize, as I said earlier with the diagram, that our API Connect instance is not configured. That means that we have deployed the different components on the different clusters where they belong, but then we need to do a post-installation configuration so that all of those components are registered together, so the control plane, this Cloud Manager, knows what gateways it needs to control and manage and publish APIs to, etc., etc., and where those different components are. For that, as I said in the diagram, we have Openshift pipelines. And as I said when I explained this GitOps Springboard structure, we are deploying those pipelines as part of the GitOps process. Remember that third layer about applications? In there, I have defined the following pipelines. So if we go to pipelines, and these pipelines are deployed under the CI namespace, we can see that we have two pipelines. The first one is for that post-installation configuration, whereas the second one will take care of publishing the product and APIs definitions that we have stored as code in GitHub as well. So we can go ahead and execute the first pipeline. So this pipeline is parameterized so that you're able to specify where the code for this pipeline is stored, what branch, what namespace is API Connect, or the API Connect instance that we want to configure is within your cluster. And then we need to provide, in this case, the different availability zones where API components are installed. So in this case, we saw that we have a gateway and analytics component both in an IBM Cloud cluster as well as in another cluster in Amazon. So my availability zones are IBM Cloud and Amazon. And also I need to provide the OCP domain for those clusters so that this config pipeline is able to configure those components based on those OCP domains. So I provide in the IBM Cloud domain for my cluster and the Amazon domain for my other cluster. So once I fill up this configuration for the pipeline, I just go ahead and execute the pipeline. I can see the different steps that are running at the moment, and I can follow along in the logs section. Once this pipeline finishes, if I go again back to the Cloud Manager and check the topology section, Now I can see that my API Connect instance or this control plane has been configured so that I can see the two availability zones and the analytics service as well as the gateway service for each of those availability zones, as well as the portal component that is in the default availability zone, which is the management control plane. Now, if I go to the clusters that are hosting or running these gateway and analytics components of API Connect, and I go under the dev namespace, I can see the following app running, which is the application that I referred to earlier that is getting deployed with this GitOps process as it is defined on the third layer applications within my GitOps framework. So just showing that we have that application, that dummy application that we want to access and that is exposing an API that we want to expose through the gateway component that that's being installed in these clusters. So as I said, the way that we do that is by first of all logging into the API manager. Since this is a first installation of API Connect, we will see that we have the out-of-the-box sandbox catalog, but then we don't have any products or APIs within this catalog. So right now I have the gateway component and analytics component running on those clusters where my applications are running alongside, but there's no API from those applications actually published on this API Connect instance and therefore exposed through these gateways. One other thing that I want to show though is that the API Connect configuration pipeline has configured these two gateways to be the gateways where this sandbox catalog will publish the different APIs to. So we see that we have the gateway on the Amazon cluster as well as the gateway on the IBM cluster set up for this sandbox catalog so that any API that is published to this sandbox catalog will be available through those gateways. Now, the last step finally is to run this publish products and APIs pipeline. And once again, this pipeline is the pipeline that will go to the GitHub repo where you have defined as code the products and APIs that you want to have on API Connect. So once again, this pipeline is parameterized so that you are able to flexible say where the code that the pipeline needs to execute is, what branch, etc., as well as what is the GitHub repo where I have my product and APIs definition stored so that the pipeline goes there, see what's in there, and then publish those to API Connect. And then you can run this pipeline over and over. In this case, we're doing this manually for demonstration purposes, but in a production environment, this pipeline will get triggered after any change on the GitHub repo so that if there is any change to an API, to a product, if there's a new product or API, those changes get immediately reflected on API Connect. So once again, we start the pipeline, we see different steps that the pipeline will go through. We can follow along within the logs tab, but after this has been executed, we should see in our catalog within the API manager that now we have a product and an API, which is the API of the applications or the application that is running in both IBM Cloud and Amazon clusters, and the one that we want to expose through the gateway components running on those clusters as well. So now to test this, all we need to do is to get the URL of each of these clusters and then try to invoke our application API. If we do so, then we will see that we are able to access that application. So effectively, we have exposed the API through the gateway. And you can see that if we poke the gateway that is on the IBM Cloud cluster, or well, in this case, the Amazon cluster, then the application is telling us that the request has been made from that gateway. So you are poking the gateway on Amazon, and then the application running on Amazon is telling you, yeah, I'm running on Amazon. Now, if we do the same, but with the IBM Cloud Cluster, if we poke the API on that API Connect gateway component, then what we get back is actually the IBM Cloud domain. So effectively, as we saw in the diagram, depending on what gateway you are poking to, then you will get access to the application running on that cluster. Now, this should conclude the demonstration of how, using GitOps approach, we can implement a hybrid scenario for API Connect, where we have the different components of API Connect running on different clusters. As we saw in the diagram, we will have a cluster that will run the control plane of API Connect, which is the management and portal components, whereas we will then have two clusters, one running in Amazon and another one running in IBM Cloud, running our applications. And then we want to run on those clusters the gateway and analytics components of API Connect, so that we can expose our application APIs on a secure manner, as well as have those APIs published and socialized on IBM API Connect developer portal. The last thing that I want to talk about is these Cloud Pak production deployment guides, which is a website where we are putting all of the documentation, assets, instructions, etc. around anything that we are doing with the different IBM capabilities. In this case, for API Connect, if you go into the tutorials section, you will see a subsection for API Connect, and then the different steps, very detailed, very in-depth, that you need to follow if you wanted to execute and implement this multi-cluster, multi-cloud hybrid API Connect scenario. From creating the clusters to configure the clusters with Argo CD, then how you connect Argo CD with the GitHub repos, where you have defined the different components that you're gonna get installed on your Openshift clusters, that we saw it's done through the Bootstrap application, and then how you configure API Connect with the different pipelines that we are providing. So I hope that this demonstration was useful and helpful for you, and thank you.